In last video, we learned about the refraction of light. When a ray of light was passing from air to glass, it bent towards the normal, and when it was passing from glass to air again, it bent away from the normal. Now we are going to discuss about the refractive index. This refractive index tells us how denser is the medium in which the ray of light is entering. So for example, imagine this line is separating two medium, air and water. As you know, when the ray of light will hit this surface which is separating the air and water, it will bend towards the normal because water is denser than the air. Let me draw a normal here. This is normal, n dash and n, and the ray of light is making an angle r after the refraction. So this is angle of refraction and this is angle of incidence. To find out how denser is the second medium, in this case water, compared to air, we use a formula which is called as Snell's law. And Snell's law is sine I by sine r is equal to n. Now what is n here? N is refractive index. Refractive index. Now this speed of light in medium 1 could be taken as v1 and speed of light in medium 2 could be taken as v2. By using the speed of light, we can find the refractive index. So refractive index could be found by using sine I by sine r, or we can find the refractive index by using the speed of light in the two mediums. Why is it so? The reason is when ray of light enters from one medium to another medium, its speed changes. So as it's entering from air to water, water being optically denser, the speed of light will decrease in water. So when we will take the value of v1 and v2 in the form of ratio, what we are going to get is we are going to get the refractive index of this second medium. Now imagine if the same ray of light is passing from water to air. Now the water is first medium and air is second medium, and here is the ray of light which is hitting the surface at an angle, let's say I. Now the angle of incidence is in water. So when the ray of light will go in air, it will bend away from the normal. And this is the new angle of refraction. Since our medium is changed, earlier it was air to water, now it's water to air. So to find the refractive index of water in this case, why I'm finding the refractive index of water here also? Because most of the time we find the refractive index of optically denser medium, and water is here optically denser medium, though it's the first medium. So what we can do here, we can take the reciprocal of refractive index and rest of the things we will keep as it is. So 1 by n is equal to sine I by sine r. This one is giving us the refractive index of water. Now we can find it in the form of speed of light as well. So 1 by n is equal to v1 by v2.